Hi, in this video, I'm going to talk about the two sample tests. Okay, so we'll be talking about the hypothesis test for two samples and the confidence interval for two samples. Okay, so in many cases, researchers want to compare two means using their samples. For example, using experimental and control groups. So you want to, if somebody wants to study whether a certain drug can raise the blood pressure or can lower the blood pressure or not, you want to compare the average blood pressure of the group of the people who are taking that drug and the group of the people who are not taking that drug, right? For example, so you may want to compare the two groups of people. All right, so look at this example. The amount of certain trace element in blood is known to vary with standard deviation 14.1 ppm parts per million for male blood donors and 9.5 parts per million for female donors. A random sample of 75 male and 50 female donors yield concentration means of 28 and 33 parts per million respectively. Can we claim that female have a higher trace element on the blood than male? So this is just one example. Okay, so you can make so many examples, you can discuss so many examples where you want to compare. Okay, so let us see another example. Imagine a researcher who wants to determine whether or not a given drug has any effect on the scores of human subjects performing a task of extrasensory perception, that is called ESP sensitivity. So he randomly assigns his subjects to one of two groups. 900 subjects in group 1 receive an oral administration of a drug prior to testing. In contrast, 1,000 subjects in group 2 receive a placebo. For the drug group, the mean score of the ESP test was 9.78, that is X bar, and standard deviation is 4.05, that is the sample standard deviation, right? Because it is for the sample. N equals to 900, and for the non-drug group the mean is 15.10, standard deviation is 4.28, and N is equals to sample size is 1000. So can we conclude that the drug hampers the ESP sensitivity? So these kind of things, how do you do that? Is you find out the average for the control group and average of the drug group, and then you can compare those, which one is bigger actually, which is bigger in the population. Okay, so we can do the hypothesis testing. We can compare by testing the hypothesis of the difference, okay, or just test the hypothesis of the equality of the two means. Similarly, we can test the hypothesis for the equality of the two proportion, two variance, and so on. Okay, so let us talk about the very first case, testing the difference between two means independent samples, sigma 1 and sigma 2 known. So first of all, what do you mean by independent samples? Is two samples are called independent if the sample values from one population are not related to or paired to the sample values from the other population. So when you collect the sample, if you are collecting two samples, if none of the people in first sample are in the second sample, they are actually independent. But if you, for example, if you take a sample and if you measure the blood pressure, for example, and then you give a drug and then measure the blood pressure again after giving the drug, so that is a dependent sample because you are taking the same subjects. Okay, so as long as you are taking the different subject, then most of the time the samples are independent. Okay, so for example, if a group of 50 people were randomly divided into two groups of 25 each in order to test the effectiveness of new drug, where the group get the drug and the other group get where one group gets the drug and the other group gets a placebo, the two samples are independent of each other. Okay, so what are the steps? So comparing the equality of two means is same as testing whether the difference between the mean is equal to 0 or not. That's the same concept. Okay, because previously we used to do mu equals to 50 or mu equals to 70 like that, but here you are doing mu1 minus mu2 equals to 0, mu1 minus mu2 greater than 0, less than 0, and so on. Okay, not equals 0 for the two tail like that. Okay, let us first state the assumptions what are the assumptions that population must satisfy and the sample must satisfy in order to use the method that we will be discussing here to compare the means. Okay, that's the next thing that I'm going to talk. Okay, number one assumption is both sample must be random sample, because we are comparing the two population using two samples. Okay, so to do the hypothesis testing by the method that we are going to discuss, both of the sample that you took must be randomly selected, random sample. The sample, those two samples must be independent of each other, meaning that same subjects should not be taken on those two data collection. Okay, that is, there can be no relationship between the subjects in each sample. The standard deviation of both populations are known. See, because it says the title of this is sigma 1 and sigma 2 are known, meaning that in this case the standard deviation of the both populations must be known. If the sample size are less than 30, each sample size, each population must be normally or approximately normally distributed. Okay, that means the population must be bell-shaped if the sample size is less than 30. If the sample size is bigger than 30, we call large sample. In that case, it is okay not to have the population normally distributed. Okay, guys? All right. So what are the steps? So the step number one is the null and alternative hypothesis, right? Number one is write down H0 and H1. So previously we used to have just mu equals to something, right? And then mu equals to something for H0. But here what we do is we do mu1 minus mu2. The difference is equals to 0. That means there is no difference between the mean of the two populations. That's what it means, right? That is same as mu1 equals to mu2. That is same as mu1 equals to mu2. Okay, meaning two populations have the same mean versus two populations have the different mean, or one population has bigger mean than the other population, and so on. So there is the right tail. This is the null hypothesis, right? So it could be greater or equals to or lesser equals to for the null hypothesis. It doesn't matter because it needs to have an equal sign there. Now, so what is the alternative hypothesis? Is either it must have less than 0, that is the left tail test, or greater than 0, that is the right tail test. Sometimes though, you can test the hypothesis for mu1 minus mu2 equals to something, some number. What does that mean? That means if you are asked to test a hypothesis so that the difference between the mean is like 10, test the hypothesis that the difference between the two mean is 10 versus greater than 10. In that case, you will have like mu1 minus mu2 equals to 10, and then mu1 minus mu2 not equals to 10, that is 210. Greater equals to 10, and then lesser equals less than 10, lesser equals 10 versus greater than 10, like that. Okay, so you can, instead of 0, you can have a number as well. There, no problem. You can test that type of hypothesis too. That is number one. Number two is finding the test statistic. Again, the same steps. Test statistic we denote by G. Why? Because sigma 1 and sigma 2 are known. That's why we denote by G. So the formula here is x1 bar, meaning this mean of the sample first sample minus x2 bar, okay, minus mu1 minus mu2, divide by, and then you do sigma 1 square over n1 plus sigma 2 square over n2. That's what you do. Okay, so this is the formula to find out the test value. All right, so x1 and x2 bar are the sample means. mu1 and mu2 are, mu1 minus mu2 will be 0 in this case because we just put the value of the null hypothesis there, right? Sigma 1 and sigma 2 are the standard deviation, so sigma 1 square and sigma 2 square are the variance. N1 and N2 are the sample size of those two samples. Okay, that is number two. Number three is critical value and the critical region. So again, to find out the critical value or the critical region, it depends on whether it is left tail or right tail. Okay, so I can do with two different methods. So it is p-value method and this is critical value method. This is alternative method. Okay, critical value method is alternative. Okay, so I will do some problem using the critical value method, but most of the time I focus on the p-value method, critical value. We find out the critical value and then critical numbers. Okay, how do I do that? Depending on the alpha value and then the tail of the test. Okay, so how many tail, is it left tail, right tail, or two tail? we will shade the normal distribution depending on that. If it is left tail, you will shade on the left only, and then that alpha value will go there. If it is right tail, you shade on the right end only, and the alpha value goes there. If it is two tail, you find out the alpha half, and then you shade both left side and the left end and the right end of the region. Okay, left region and the right region, and you find out the critical values. All right, and then number 4, look at this. I have mentioned how to find out the critical value. You do q norm alpha 0 1 for the left tail test, q norm 1 minus alpha, and then 0 1 for the right tail test. Okay, and plus minus q norm alpha half 0 1 for the two tail test. That's what you do. Or another method is the p-value method. Again, it is exactly similar. What we do is we find out the value of that. You find out the value of g and find out the area. P-value is the area right to the g, right of g. If it is right tail, left of g. If it is left tail, this is right tail, this is the left tail. Okay, and then this is for the two tail. If g is positive and negative, we use the exactly the same idea that we did in the one sample test. Okay, and this is another summary, exactly the same, meaning if p-value is less than alpha, you reject the null hypothesis. If p-value is greater than alpha, you do not reject the null hypothesis. Okay, so number 4 is basically the decision. Okay guys, so what I am going to do next here is, okay, so what I'm going to do here is I'm taking one example, and I will do this example by using critical value method and p-value method. Look at that, the data is not given here. The sample information about the sample is given, data is not given. So I'm not using the R for this to do the hypothesis test directly, but I will show you the step by step. Okay guys, so first of all, let me read the question, and then let me write down what are the given information about the sample and the population here. So I am going to do that here. Okay guys, all right. Okay, so the average length of short hospital stays for men is believed to be slightly longer than that for the woman. That's the belief. So the people spend a longer time in hospital than the male patient spend longer time in the hospital than the female patient. That's the belief. People believe that. A random sample of recent hospital stays for 32 men. Let's do x1, because this is the sample values. x1 bar is 32, and then x2 bar. Oh, by the way, this is not x1, n1, right? I'm sorry about that. So that means n1 is 32, that is number of people in the male, right? So 32, and n1 is 32, and then n2 is 30. Okay, this is given. Reveal that the sample average was 5.5 and 4.2. So that is x1 bar is 5.5 days, and then x2 bar is 4.2 days. 4.2 days. Okay. At alpha equals to 0.01, is there sufficient evidence to conclude that the average hospital stay for men is longer? It says is mu1 is greater than mu2. I'm assuming that mu1 is male and mu2 is female. Okay, for the hospital stay. If mu1 is greater than mu2, that's what it is asking. Okay, so what it's saying here further is the population standard deviation for the men and woman is 1.2 and 1.5. So sigma 1 is 1.2, and sigma 2 is 1.5. This is given to you. Okay guys, so how do I do the hypothesis testing for this? So again, so h sub 0 is mu1 minus mu2 equals 0, because we are comparing if they are equal or one is bigger than the other. Okay, so for equal, this is the null hypothesis, and for the alternative hypothesis, you write mu1 minus mu2 is greater than 0. Mu1 is for male, man, and then mu2 is for woman. Okay guys, now this is the formula to find out the g value. Okay, how do I find out the g value? Is you find the x1 bar minus x2 bar, because this will be 0, right? Mu1 minus mu2 will be 0, so this guy will be 0, x1 bar minus x2 bar is 5.5 minus 4.2, right? So 5.5 minus 4.2 divided by sigma 1 square is 1.2 square over n1 is 32, and sigma 2 square is 1.5 square over 30. So this whole thing is under the root, okay? And you find out that number. Let me see if I have done exact the same problem. Look at this. You see that? N1 is 32. I wrote that N1 is 32, N2 is 30, X1 bar is 5.5, X2 bar is 4.2, alpha is 0.01, right? That's what the alpha is. And then what is sigma? So sigma is 1.2 and sigma 1, and sigma 2 is 1.5. Now what is the value of G? Is X1 bar. Look at that. X1 bar minus X2 bar. See, there is a parenthesis minus 0. That is minus 0. And whole divided. See, for this one, I have enclosed the whole numerator by a parenthesis. And for the denominator, it is square root sigma 1 square over n1 plus sigma 2 square over n2. Let me find out how much is that. So the G is 3.75. That's what I got here. So 3.75. Okay. So let me write down that 3.7527. So 3.7527. That is the G, or the test value. Okay. Now what is the P value? So it is right tail test, right? So the P value will be, P will be area right side of that value, because it is positive. Okay, right of 3.7527. How do I do that? It is P norm, right? P norm. Oh, by the way, since it is right tail, you should do 1 minus P norm. Why? Because for the right tail test, see, you want to find out the area right of that test value G. You have to find out that area. To find out that, because the P norm, so P norm always find out the area left. P norm always find out the area left of that Z value. Okay. So if you do P norm 3.7527 and then 0, 1, because it is normal distribution, P NORM. Okay, so if you do this one only, then it will find out the left area, but you want to find the right area, that shaded area. So that is 1 minus the total minus the left area is that. Okay, so if you do that, what do you get? Let me find out that. Look at this one. This is what I want you guys to do in the homework. Okay, if I give you homework like this without data. All right, so if I do that, that P value is very small actually. So that is 8.744. That is 8.7443 times e to the negative 5, means 10 to the negative 5. What is that actually? It is 0.00008. See, and then 74. So that's what it is. So which is less than alpha, right? This is less than alpha. What is our alpha? Alpha is 0.01. So we reject the null hypothesis, right? So we reject 80 because P value is less than alpha. Now, if you want to do the critical value method, how would you do that? That is the thing. Okay. So what is our alpha? Alpha is 0.01, right? Since it is right tail, because the question is greater than 0, right tail. In this case, you will just, so you will just set the right side. So that is 0.01. Okay, for the 0.01, you want to find out that G alpha value. Okay, so how do I find out? You need to, since you are finding this G alpha value, here G was given like this. G was given, and you will finding the area. So you use P norm. But here you are finding the G alpha. Okay, so we need to use the Q norm for that. G alpha equals to Q norm, the left area, left of that area. What is that? 0.99? 0.99. You see that? So how much would that be? So let us find out that Q norm and then 0.99. So let me do it here. I haven't done that there for the with the critical value method. So I would do Q norm and then 0.99 and then 0,1, right? If you do that, you will get 2.33. That's the value of G. That is basically 2.33. So idea is exactly the same. Okay, 2.33. Now, how do I make the decision? Is is that value fall in the shaded region? Is that value from step 2, is this value fall in the shaded region or non-shaded region? If it fall in the shaded region, then we reject the null hypothesis. If it does not fall in the shaded region, then we do not reject the null hypothesis. See, the test value is 3.75, which is bigger than 2.33, right? So it may be somewhere here. So meaning we reject the null hypothesis. So we reject H0. So it is the same conclusion from both. But how do I write down the conclusion is? So we need to look at the wording. So it says, with alpha equals to this, is there sufficient evidence to conclude that the average hospital stay for men is longer than the average hospital stay of women? We rejected, right? We rejected means we supported that. Okay, so I am basically supporting this, right? Hence there are enough evidence to conclude that the average hospital, let me write AV, average hospital stay of men is bigger than that of women. So also you can say that the main hospital stays is significantly bigger than the woman hospital stays. Okay, you can say that way too. So that's what I have written here. Look at this. Since P is less than alpha, we reject H0. That is null hypothesis. Hence, there are enough evidence to conclude that men have longer short-term hospital stays than female or than woman, right? So woman. That's what we conclude here. Okay. So there is another example here. So similar example. Okay. So exactly similar example. You have x1 bar, x2 bar, n1, n2, sigma 1, sigma 2. That's what we were needing here. And alpha is given as 0.05. So I have done this problem. So in R, so how did I do? I did exactly same thing. N1 is this, N2 is this. I just copied there. Okay. So from slide number, I think this is slide 10, right? Okay. See, I have example from slide 10. N1 is 43, N2 is 32, X1 bar is 84, X2 bar is 89, and then so on. And alpha is, see, I just copied everything from there. Okay. So now, what is the null hypothesis? Let's read the question and then decide. Okay. A medical researcher is interested in finding out whether a new medication will have any undesirable side effect. The researcher is particularly interested in the difference in the pulse rate of the patients who take the medication versus the control group. Take the medication versus not taking the medication. For the patient who take the medication, will the pulse rate different? So this is the two-tail, right? It says different from. The patient who do not take the medication, these are the given information there. Okay. So how do I do that then? So look at this. So the null hypothesis is equal, and alternative hypothesis is not equals 0, right? Two-tail test. So find out the test value x1 bar, g equals to x1 bar minus x bar minus mean is 0. Divide by square root of sigma 1 square plus sigma 2 square divided by and sigma 1 square over n1 plus sigma 2 square over n2, right? If you find out that, it will be g, and then since this is two-tail test, and then it depends on what sign do you see. If you get positive sign, you will find out the area right, 2 times the area right for the two-tail test. If you get the negative sign, then you will get 2 times the area left. Okay. So let us run this. What do I get? Okay, let me clear what I have first. Clear the console, and then let me run that from line 39. So that is N1, N2. I just copied those, okay, from the question. So the G value is negative 7.41. That's what I get, the G value, okay. So G value negative 7.41 means it is negative, right? So it is on the left side actually. So to find out the P value, what do you do then? P value is the area left of the test value. You see that? So if you want to find out the p-value there, so what is happening there is 0 is there, right? So it is left tail test, it is two tail test. Okay, if you are using the critical value method, then you need to shade the left side and right side and you find out the critical value. But since you are using the p-value method, you don't have to shade anything there. What you need to do here though is that is the g is the test value is negative 7 point something. So maybe this is the g, this is the test value, negative 7 point, let's say 42, negative 7.42. So what you need to do is you need to find out the area left of that. Okay, to find out the area left of that, that is the p, will be p norm. P norm always find the area left of that, right? So p norm negative 0.7, so 7.42 and then 0, 1. That's how you find out the p-value there. Oh, by the way, there is 2 times as well. So because it is two tail test, 2 times that. So when you do that, you get basically p is very, very small. See, 10 to the power negative 13. So which is very small. Since p-value is less than alpha, we reject the H sub 0. That is the null hypothesis. And there are enough evidence to conclude that patients who took the medication have significantly different pulse rate than the control group. Okay, that's what I got. And then let me tell you this note. I think I mentioned that earlier. Okay, you can find out sometimes you may be interested to test hypothesis on the mean of two populations differ by short number. Instead of mu1 minus mu2 equals to 0, you may be doing mu1 minus mu2 equals to a number there. All the steps are same, but the null hypothesis and alternative hypothesis will look like this versus either this or that one. Okay, so so the 1 minus alpha confidence interval for the two sample test of mean when sigma 1 sigma 2 given is this. Okay, so x1 bar minus x2 bar minus g alpha half and then root under, this is basically the standard error, right? And then is between, so mu1 minus mu2, the difference in the population mean is between this number and that number. Okay, so note that if 1 minus alpha confidence interval for the difference between two means contains 0, if the interval contains 0, then we do not reject the null hypothesis. And then if that interval does not contain 0, then we reject the null hypothesis. So this is another way of testing the hypothesis by using the confidence interval. Okay, let us do one example and then for this type of problem. Okay guys, all right, let's see that. A sample of 82 rabbits were divided into two groups, 40 and 42. Okay, let us write down what is given there. Okay, so there were total 82 rabbits, so n1 is 40 and then n2 is 42. And administered a drug. Blood samples are taken from each animal and the times to clot are recorded. The average time to clot for the first group is 8.75 minutes. So x1 bar sample mean is 8.75. And then for the another group, it is 9.81. Okay. Assuming the population standard deviation for the group is, that is, sigma 1 is given as 1.25 and then sigma 2 is given as 0.9. It is given like that. Construct a 98% confidence interval. So we need to find out 98% confidence interval. So 1 minus alpha is 98%. So what will be alpha then? Alpha will be 0.02 because 98 is 0.98, right? So and then alpha half will be 0.01. Okay, so what they say is construct a 98% confidence interval for the difference between, see, it is like a two-tailed test, right? Between the means from the confidence interval, can we claim that the mean clot time between the two groups rabbits are not equal? That is what the two-tailed test give. Okay, so this is where you will get the two-tailed. So this one is just you are finding the confidence interval for the difference, and this one is, can we say that the clot time for those two groups are equal or not equal? That's what we want to test. Okay, what I'm going to do here is I will enter all these things, okay, in the R and then follow exactly this same formula here. I'll follow this formula to find out the confidence interval. Let us see that. So N1 is so n1 is, let me make it a little bit small so that you can see those things there. Okay, so look at that. So what is n1? N1 is 40 and n2 is 42. X1 bar is 8.75, x2 bar is 9.81, alpha is 0.05, sigma 1 is 1.25, sigma 2 is 0.9. Okay, so alpha is 0.05 as, oh, alpha is 0.02, right? See, because it says 98%. So let me make 0.02 there. So this is example from slide number 12, this slide. Okay guys, this is slide 12. Okay, all right, now let me run these. So all those given things, now confidence interval equals to, what we are doing here is basically I'm doing C here. Why? Because there is a comma in the middle, because there are two things. So if you are listing two things all together, then you need to write C. If you are not listing the two things, if you need just only one thing, then you don't need C and then parenthesis. See, there are two things separated by comma. Look at the formula there. There were two things separated by comma there, right? I mean, in the formula. See, you can find out this one and then comma and then that one, right? Although you can write in the inequality form. So this is how you find out. So there is a C. See the formula, x1 bar minus x2 bar. Let me show you that formula there. X1 bar minus x2 bar, and G alpha half is basically the, so negative G alpha half. Negative G alpha half is Q norm, because see what is happening there is, so alpha is equals to, alpha half is 0.01. So since it is like confidence interval is two-tailed like that, it is two-sided confidence interval. Okay, so it is like alpha half is 0.01, this is 0.01, so it will be denoted by negative G alpha half. This will be denoted by positive G alpha half. Okay, so to find out that, negative G alpha half will be Q norm, okay, and then 0.01 and then 0.1. If you do that, it will give you the value. Okay, similarly for this one, you will do Q norm 0.99, because this is 90% and 98% is in the middle and 1% on left. So the total will be, for G alpha half, it will be Q norm and 0.99. That's what you will do there. Okay, let us see that. So why did I do plus Q norm, but although there is a minus sign? Because negative G alpha half is positive Q norm. That is the reason. Okay, so that's what I did here. Okay, and then look at that. So and I'm putting that alpha half there. So see, x1 bar minus x2 bar plus Q norm alpha half, and then comma 0 comma 1 times square root of sigma 1 square over n1 plus sigma 2 square over n2, comma, for the second one, what is the second one is the same thing, x1 bar minus x2 bar plus G alpha half. So why did I do that? So the plus G alpha half will give you, this is the positive G alpha half. What should you do for that? So one way of doing this is, you can do 1 minus alpha half and then do the plus here. Okay, so what you can do is, you can write plus and then the area. So this G alpha half is, so that what is the value of positive G alpha half? Positive G alpha half equals to Q norm and then 0.99. That is 0.99 means 1 minus alpha half, right? 1 minus alpha half and then 0 comma 1. You can do that and then write down plus here and then 1 minus alpha half. 1 minus alpha half. Okay, and then the other terms are under the root sigma 1 square over n1, sigma 2 square over n2. Let me find out that. I ran that alpha half already. If I do that, I got negative 1.6219 and negative 0.49. Is the 0 is the null hypothesis, that is 0, because here on this problem, what was the problem here? It was like H0 is mu1 minus mu2 equals to 0, and H1 is mu1 minus mu2 not equals to 0, right? So since the 0, that value, since this value does not fall, that 0 does not fall here, okay, so we reject the null hypothesis. Okay guys, see, since 0 is not included in the interval, we reject the H0. Hence there are enough evidence to support the claim that the mean time are not equal, or you can say the mean clock time are different. Okay guys, so this is how you can do. So there are other example that I mentioned. If so these are the practice problem, or the I would say these are the homework problem. Okay, so these are the homework problems. So I will write that in the homework. Okay, I will just post that in the homework, that I will ask you, hey, you should go ahead to the slide 14, and then this is slide number 13. You'll have to go ahead to the slide 13. Yes, this is 12, so this one is 13. Go to the slide 13 and then do example 1 and 2. But this is how you will do. Okay, this is how you will do. All right. So let me see. The next one is sigma 1 and sigma 2 unknown, so we will do that in the next video. Okay guys, all right.